G'day everyone, how's it going? Welcome to another episode of Mr. Code's STEAM podcast, and where we talk about everything science and technology after school. My name is Gary, and today we're going to be talking about some intelligent drone formations. We're coming at you live, so make sure you write your questions in the chat channel, in the chat window, if you have any questions, and I will try to answer them when we get a chance. So if you like these videos, make sure you subscribe to the channel as well, okay? So if you have any questions, type it in the chat or in the comments. So if you're watching this and it's not live, then type it in the comments and I'll definitely try to answer you. So in the last couple of weeks, we learned about how a quadcopter drone flies and how they differ from traditional aircraft. We also talked about how we can create automatic drones. So these drones can perform delivery functions to transport time-critical supplies through the air. And a key component of this is a sort of navigation method. So for our drones, we have a sensor on the bottom of the drone, which scans for QR codes. And this scanner will help the drone understand its location in a certain space and it keeps track of its position so that we can then communicate to other drones, other computers, and also get things running. All right, let's see. We can see how many people are asking questions. Excellent. So it looks like everybody is going well. All right, let me get this presentation started. Okay, so today we examine some of the applications of drones flying in groups to achieve some sort of mission. If you saw this scene during the Olympic opening ceremony, then you might have noticed this amazing little picture of this globe that they created. So this globe was created using the lights of hundreds of individual drones. So it looks absolutely stunning, but the drone formations are not just limited to entertainment. This is because drones themselves have huge utility value as well. One of the things that drones do really well is surveillance. And in Australia, drones are now regularly being used in agricultural, mining, and forestry industries to survey the land. Drones are great at surveying landscapes quickly and efficiently to put people out of harm's way. On a farm, drones can cover vast distances to monitor the condition of livestock, fencing, water supplies, and so forth, which means that more work and more productivity can come from the people who are in charge. So the farmer doesn't have to do so much traveling. The people in charge don't have to physically go out to all the corners of the farm to check for the status of the livestock. They can do this remotely using drones. Powerful sensors can be mounted onto the drones to monitor things like bushfires, oil spills, gas leaks, and especially in large factories, this is really, really important to keep things in check and to keep people out of harm's way. They can even help detect things like unwanted pests and feral animals, which can do serious harm to Australian plants and wildlife. A lot of animal control agencies might use infrared cameras, and they can actually see in the dark and have drones sort of patrolling areas of concern so that they can keep track of any pests or feral animals. And because of this great utility value of drones, the amount of drones being used will eventually increase. And as the number of drones increase, it becomes more and more important for them to be able to avoid crashing into each other. And this is what we see when we watch a drone formation. It is a group of drones that are coordinating with each other through time synchronization and also awareness of their surroundings. However, time synchronization is easier said than done. For example, if two drones are traveling really closely with each other, then there is very little time for a drone to react to the other drone if it starts to move towards it. So these drones are traveling really close to each other. So how does it sort of coordinate with this other drone so that this other drone doesn't bump into myself? Well, the way we solve it is to use an external conductor. Okay, and in our case, we're going to use something like this. It's a wireless router, and this acts like a train conductor. So a conductor is going to say, everybody, this is how you should be moving, and 3, 2, 1, go. This is the timing to do it. So no one drone is in charge of another drone's timing. An external conductor is determining how the drones move. And this is really important because only the external kind of conductor will know precisely the timings that the drones are going to move. Because otherwise, if the drones just had used their own sensors and relied on their own sensors, they would not be able to react in time. And that is why an external conductor is really important. Furthermore, a drone's clock is different for each drone, right? So when they synchronize, it's important for them to understand, okay, whose clock are we working from? We're not working from each individual drone's clock, we're working from this conductor's clock, and this conductor is going to transmit the instructions for everybody. All right, let's see if there are any questions for now. No, looks like we're still going well. Again, welcome to the channel if this is the first time you are watching this stream, okay? If you're enjoying this video, please make sure you like and subscribe. Okay, so how does drone synchronization work? So we talked about how we need an external conductor, and sometimes we also need external sensors. Now, for example, if you look at this image of this drone performing this really delicate maneuver where it has to fly sideways through this gap, you can see that this isn't actually done by a human. This drone is actually flying automatically. But how does it know how to fly through this gap? Well, you see at the corners of this room are actually cameras. Okay, and these cameras are feeding back information to the drone to tell it how to fly. And this external conductor is really important to keep a formation drone in check, because otherwise the drones themselves, they don't have enough sensors on board to recognize all of its surroundings. They might have some, but they don't have everything. So these external sensors and these external conductors are really important for synchronizing the drone to making sure that the drone is working in the right way. Okay, in Tokyo, they had something like 25 teams of drone operators, and each team was in charge of looking after things like sensors on the ground and also sensors on the drones, because the sensors are not just limited to what's on the drone. We need to also have external input to tell the drone where to go. And in a search and rescue scenario, drones can be used to help people and locate people to rescue. But these environments, such as the aftermath of like a flood or an earthquake, could be really difficult to traverse on land. And furthermore, obstacles like trees or buildings can prevent the use of helicopters. So this is when small coordinated teams of drones can make much better use of this kind of difficult terrain and these small gaps. You can see here we got a line of drones, and these drones can actually change their formation to fit through gaps and navigate and give life-saving aid to people who need it, or it can be a surveillance drone to help rescuers find out where people are located, where they need to be focusing their efforts. Okay, have we got any questions so far? Are we going to fly a drone? Yes, we are definitely going to fly a drone, which brings me to the next part. Let's have a look at the code. So for our drone here, we are going to fly a LiteBee formation drone. And for LiteBee, these drones do not have an external sensor. They all have onboard sensors, but they do synchronize through a router. And how does the code work? Now, there's a big string of code here which represents the maneuvers that these drones need to perform. But what I want you to concentrate on is the method that we use to synchronize the drones. So right at the start, it's very similar to Scratch, right? We hit the flag to say go, but then all these commands are not executed live. These commands, like move to the QR code number 15, for example, this is actually a plan that we send to the router, okay? And the router will also pass this plan on to the drones. So this is not executed in real time. This is not like Scratch where when you move a sprite, it moves in real time. This one is a plan that gets sent to the router. And what happens is that this plan, all the way down to the end of all these moves, what it does is this says that we upload this whole plan for this first drone. So we're going to have 4 drones, and they're represented by these 4 little bees over here. So these 4 drones, sprite 1, 2, 3, and 4, the first drone will load all of its moves and then broadcast an event called message 1, which represents that drone 1 has received all of its instructions, all of its plans. What happens to message 1? Well, message 1 actually gets handled by drone number 2. So drone number 2 will receive message 1, and it will go, okay, the first drone has all of its plan. Now we're going to load all the plan for the second drone. Okay, so all these moves just represent different movements on the map. We don't need to worry about that too much because you'll see how it looks in the moment. But then what it does is after all of the plan for drone number 2 is loaded, then it broadcasts message 2. And then the third drone will handle message 2. When the third drone receives message 2, then we also load up the plan for drone 3. And then it broadcasts message 3 to say that the third drone has received all of its plans. And then drone 4 is also taking in the message that drone 3 is complete. Then it loads up its plan all the way to the end, and then it broadcasts message 4. And then message 4 is when the first drone will know that all the drones are now correctly synchronized. See? So right up here, when you receive message 4, then it will show a ready symbol, and then the programmer will know that all the drones have all the code ready to run. So this is kind of like a daisy chaining code, right? If you've done EV3 and you remember daisy chaining, this is kind of like that, where each sprite is waiting for the previous sprite, or each drone is waiting for the previous drone to make sure that all the information is loaded. And then right at the very end, the first drone will get the go-ahead message so that it realizes that all the drones now have the right information set. All right, so let's have a look at some questions. Okay. All right, so this isn't the drone. This is just a picture. This is the code where we are coding the drone. But the drone is actually on the floor right now. I'm going to switch the camera really soon to show you that first demonstration. Does anyone have any more questions? Cannot hear you now. Let's have a look. Can everybody not hear me? Testing. Testing. You can hear just me. Okay. Good. Yep. So it is just me right now. All right. Good work. If you can't hear me, then yeah, just type something into the chat and I'll try to address it. But it looks like we are working fine. So I'm just going to set up the drone and the 4 drones, and then we're going to see the first flight. Okay, so just hang on there for a second. All right. There were actually 4 drones there, but one of them stopped flying right at the start, and the second one sort of stopped flying halfway through. So what I'm going to try and do in a moment is to change all the batteries and then try to do the flight again, okay? But you can see that none of the drones crashed, right? So all the drones are coordinated and they move around this space, and they never actually crash into each other, and that's because of a few different factors. The first one is where we make sure we program their flight path so that it makes sense and that they are going to be really safely separated from each other. And then secondly, we have the drone sensor so that it always knows which part of the map it is on by looking at the ground, by looking at the QR codes on the ground. You can see that when the drone reaches like a destination, it sort of snaps into position. And that's how the drone is able to navigate around. Have we got any questions so far? All right. I'm going to try to do the drones one more time. So just bear with me and we'll see if we can get this formation flying again. Okay, hold on for a second. All right, so that worked a little bit better. I think a couple of the drones might have some issues, but that's okay. I'll talk to Makerfire about that. But you can see how the drones are very mesmerizing because they are following little fixed formations and they're kind of dancing around each other and they're never crashing at with each other, which is really, really cool looking, right? Have we got any questions? No, everything is going well. Well, if you have any questions about the drones, then make sure you post them in the chat or in the comments section below, okay? So today we've demonstrated two main strategies for keeping drones in formation and stopping from them bumping into each other. Firstly, we need to make sure that they can recognize their surroundings by using something like the scanner on the bottom of the drone to recognize the QR codes that are on the ground. These drones can use the scanners to understand what position it is in space, right? And secondly, we have a programming solution where we ensure that the drones have well-planned flight paths and that they are synchronized using a router. So this router is sort of acting like an external conductor to tell the drones when to take off, when to land, and so on. In the future, maybe these drones can be equipped with even more advanced sensors and maybe even communication equipment to feed back more information to the router or to the user and adjust the formation as it's planned. So that can be the future of how these drones interact with each other. So I hope you enjoyed today's video and make sure you subscribe for more. I will see you again next time. Bye bye.